This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions. She gives the answers. No filter, no script.
Well, mostly no script.
Today we're flipping the usual AI conversation on its head. We spend a lot of time on the software, the models, the algorithms, almost no time on the hardware underneath all of it. Specifically, nearly every frontier AI model running today depends on chips from one company on one island, TSMC. This isn't geopolitical trivia. It's a hard constraint on what the AI industry can actually do, Claudine. What does it actually mean for builders when the most critical component in the stack comes from a single source?
There's a strange honesty to this topic that gets lost in most AI conversations. When any frontier model is being trained, it's almost certainly happening on silicon that came out of a TSMC fab. The software story gets all the headlines, but the entire industry sits on top of one company's manufacturing capability. And that company is on an island with real geopolitical exposure. For builders, the abstraction they're used to, compute is just a commodity I rent by the hour, has a hidden floor underneath it. That floor can shift in ways no API contract will warn them about. The useful framing isn't catastrophe planning. It's recognizing that AI roadmaps quietly depend on whether leading-edge nodes keep shipping on schedule. And that's a constraint no clever software can route around.
In 50 years, I've seen industries get badly squeezed by supply concentration. DRAM shortages, hard drives after the Thailand floods. But this feels different in scope. When a shortage hits one slice of the industry, you adjust. When it hits the thing underneath all of it, adjustment gets a lot harder. How should builders actually think about this when planning product development and AI infrastructure?
The honest answer is, plan as if leading-edge capacity is roughly fixed for the next several years, because it functionally is. A new fab is a 5-year, $20 billion commitment, and the equipment supply chain behind it has its own choke points. If your roadmap assumes compute keeps getting cheaper on the same curve we've been on, you're making a bet that may not pay out evenly. The builders making smart calls right now are designing for elasticity in both directions. They can scale up when capacity is loose, but they have a real answer for what their product does if inference costs flatten or spike for 18 months. And a lot of features get architected against the biggest model out of habit. That habit is precisely what becomes expensive when the floor shifts.
That's the don't put all your eggs in one basket problem. Except we don't have enough baskets yet. What's the realistic picture on diversification? Can the industry actually build more baskets? And can software help in the meantime?
Diversification is real but slow. New fabs are being built in Arizona, Japan, and Germany. Intel and Samsung are both trying to claw back relevance at the leading edge, but none of that meaningfully changes the supply picture for the next 2 or 3 years. Software can absolutely soften the constraint. Distillation, smaller specialized models, smarter routing, better batching. Software can stretch the capacity we have, sometimes dramatically, but it can't create new wafers. The teams who treat efficiency as a first-class design constraint, not a last-mile optimization, end up with products that survive whichever way the supply story breaks.
That distinction, first-class constraint versus last-mile optimization, is worth sitting with. For most teams, efficiency is the thing you think about after you've shipped. What does it look like in practice when teams get this right?
The pattern is less about individual companies and more about which design choices age well. Teams that built their entire value proposition on always cheaper frontier inference have had to renegotiate that promise more than once, sometimes painfully, sometimes by quietly raising prices and hoping nobody noticed. The teams that invested early in distillation, caching, and serving smaller fine-tuned models for the bulk of their traffic, those teams have a lot more room to maneuver. The cautionary version is the startup that demoed beautifully on frontier-class inference, raised on those unit economics, and then discovered the economics only worked if compute kept getting cheaper at the rate it had been. That's downstream of a hardware story, and it's the version of this constraint that actually shows up in board meetings.
Assumptions baked in early that nobody revisits until they become a problem. I've seen that movie. Let's get practical. What are the actual moves? What should someone be doing differently starting next week?
The move I'd push hardest on is decoupling your product's value proposition from any specific assumption about compute price curves over the next 2 years. Concretely, Actually write down what your unit economics look like if frontier inference costs stay flat for 18 months, and what they look like if they drop 50%. Make sure both scenarios survive contact with your board. On the strategic side, watch the second-order signals more than the headlines. Equipment orders for ASML's machines, foundry capex announcements, which hyperscalers are signing multi-year capacity deals. Those tell you more about the real timeline than any vendor roadmap will. And build optionality into your model layer early, so that swapping providers or model sizes isn't a 6-month refactor when you actually need to do it.
That last point about optionality gets undervalued. Abstraction layers feel like overhead, until the day they're not. As we wrap up, what's the final thought you'd leave with builders who want to stay ahead of this?
The constraint isn't really about TSMC. It's about the discipline of building inside a finite system. And that discipline is going to matter for the next decade, regardless of which way the supply story breaks. The builders I'd bet on are the ones who can articulate in one sentence what their product does at half the model size and twice the inference cost. If you can answer that, you've already done the hard thinking that most teams keep deferring. What I find encouraging is that the constraint is finally pushing the conversation away from use the biggest model you can afford and toward genuine engineering judgment about what each piece of a system actually needs. That's a healthier place for the field to be. And I think the products coming out of this period are going to be better for it.
The constraint forcing engineering rigor that should have been there all along. That's exactly right. Claudine, thanks for unpacking all of this. The hardware reality, the supply picture, the practical design moves. For everyone listening, know your unit economics under different compute scenarios. Build model layer optionality in early. Treat efficiency as a design constraint, not a cleanup task. We'll be back with more conversations that get into the real underpinnings of where AI is going. Thanks for joining us. Claude Code Conversations is an AI Joe production. If you're building with AI, or want to be, we can help. Consulting, development, strategy, find us at aijo.ai. There's a companion article for today's episode on our Substack. Link in the description. See you next time.
I'll be here, probably refactoring something.